Hey guys, we are working on 2.6 today. So if you have not watched 2.3, I suggest you do because it's just going to get a little bit more complicated. It's not hard, but if you don't know 2.5, you're not going to understand today's homework. So 2.6, we're talking about reference angles. All right, so let's start off with a good old definition. The definition of a reference angle is in standard position, it is the positive keyword acute. We all know what acute means. If you don't, it's less than 90 degrees. So the positive acute angle, or it can be a right angle. It won't be very often, but it can be, or a right angle, formed by the x-axis and the terminal side of the angle. Okay, remember we talked about terminal side. That is basically the ray. So if this is my that's my x-axis and xy axis. So the terminal side is where it ends. So that right there would be the terminal side. Like if I said this was 60 degrees, that would be my terminal side. Or if I said this angle here, that would, wherever your angle ends, that's your terminal side. Okay? So, let me give you some examples and we're going to talk about it. Okay? Because you're probably like, what does that mean whatsoever? So, example 1, find the terminal, or find the reference angle. Okay? So I'm going to give you A, B, and a C. And a D. Let's just do a D too. All right, 50 degrees, 130 degrees, 220, and 325. And I want you to draw a coordinate plane. Okay, as a reminder from yesterday, you start off at 0 degrees here, then you get to 90 degrees, then 180, then 270, and then you're back around to 360. That's a 6. Okay, so for A, find the reference angle. So we're starting at the x-axis. We're going up. So it is the positive acute angle formed by the x-axis and the terminal side of the angle. So we got our terminal side, right? Or I'm sorry, the x-axis there, and our terminal side there. So our reference angle for A is 50 degrees. Okay? Let's look at the next one because I don't think that was very helpful. Let's look at the next one. So 130 degrees. We know it's going to hit in quadrant 2 because it's between 90 degrees and between 180. So it's roughly there. Again, we're using the x-axis and the terminal side. Okay, except this x-axis would not form an acute angle. It would be an obtuse angle, so we can't use that reference point. So let me redraw this so you can see what I'm doing. So the acute angle, I think some of y'all probably already figured it out. So we're using this x-axis going up to here. what is the degrees from 180 to 130? If you said 50 degrees, you are correct. Okay, so this distance would be 50 degrees. So the reference angle of 130 degrees is 50 degrees. Okay? Pause it and rewind it if that does not make sense. If it does, we're going to move on. Okay? So let's look at the next one, 220 degrees. It helps if you know what quadrant it falls in. So we know it should fall in the third quadrant. Okay, so this angle is 220 degrees. So again, we are going to use the x-axis and the terminal side here. So what angle measurement is from the x-axis to that terminal side? You got 180, 220. Think about it. You should get 40 degrees. 220 minus 180. Okay? Last but not least, I'm just going to, so I don't erase it each time. We're going to do 325. Again, it's going to go into the fourth, not again, this is the first time, but it's going to go into the fourth quadrant. So I got 325. Okay? But we're going to use, let's use green. We're going to use this x-axis and here. So it is the distance between 325, and that should be a degree sign, not a circle. So this is 325. So 325 and 360, what is that measurement angle? If you said 35 degrees, you are correct. Okay? That's kind of a messy drawing, but rewind it, re-listen to it if it's confusing. Now, in general, I'm going to give you a little rule of thumb, so make sure you highlight it or you put a star, because we're going to be doing a lot with this tomorrow. So in general, if I spelled general, that would be awesome correctly. So in general, if theta, and theta means the angle, terminates in, wowzers, all right, terminates in quadrant 1, oh, there's the bell. I'm going to say theta REF, for your reference angle, equals your theta. Okay? Just like we did on example 1, problem A. 50 was our angle, our reference angle was 50. Okay? In quadrant 2, okay, what do you think we got? 130 was in quadrant 2, but 50 was our reference angle. Our reference angle is 180 minus theta. Okay, quadrant 3, our reference angle is theta minus 180. And quadrant, oh, I just put theta. It's supposed to be quadrant 4. Your reference angle is 360 minus theta. Now, I want us to put this into terms of pi as well. Okay, so for quadrant 2, it's going to be pi minus theta. Quadrant 3 is going to be theta minus pi. And quadrant 4 is going to be 2 pi minus theta. Okay. Now some of y'all might ask, okay, well what happens if we have 90 degrees? Okay, which it can happen, or 180 degrees. Okay, so if theta is a quadrantal angle, which means lies on an axis, then theta, your reference angle of theta, is either 0 degrees or 90 degrees, depending on, and if that's the case, it'll be pi over 2 for if it's in theta. Okay, so like if this is if it's one of these points, then it's going to be 0, and then obviously if it's on the y-axis, it's going to be 90 degrees because it's the distance from here to the x-axis. Make sense? Okay, now let's go back to our trig functions, our 6 trig functions. Okay, like I said yesterday, we're going to be talking way more about our circle. Ooh, imagine that was a straight line as well. Okay, we all know if I was to make a triangle, okay, this would be my x, this would be my y, right? P would be my point, and then R, I want y'all to get in a habit of that because R is our radius. That's a terrible circle, but R would be our radius of our unit circle, okay? Because R would equal the square root of x squared plus y squared. That's the distance, or that's Pythagorean theorem. Okay, a squared plus b squared equals c squared. We just square rooted it, okay? So we've got sine of theta. We know sine of theta, you're welcome. Sine of theta is our y, our opposite, over our hypotenuse. Well, in this case, it's going to be our r. Do y'all notice why we were talking about reference angles? It's because theta is always going to be this angle, okay? Or if it goes off to this side, it will always be that angle. It will always be our reference angle, okay? So sine of theta is y over r. Cosine of theta is x over r. Tangent, we know, is opposite over adjacent. So our opposite to theta is y over x. Okay, cosecant. If I'm going too fast, guys, please pause. Okay, cosecant is r over y. Secant of theta is r over x. And cotangent of theta is x over y. All right, so I'm going to give you one example. Okay, like this. So I'm going to say find the 6 trig functions. 6 trig functions for -1, 3. So I suggest you plotting, oops, that's not right, plotting your points. Okay, always draw it because it's our reference angle. Is there. So this is 3. Our, whatchamacallit, our x value is -1. So we've got cosine of theta. Oh, and we have to do Pythagorean theorem as well. So r, or to find r. So you should get the square root of 10. All right. Why did I do cosine first? So we got sine of theta should have 3 over square root of 10. Cosecant, whoa. Cosecant, square root of 10 over 3. Cosine, -1 over the square root of 10. So your secant, square root of 10 over -1. Tangent, 3 over -1. And cotangent, -1 over 3. That's it. Okay? So that ends your notes for today. Have a good night. See y'all tomorrow.